Our objective for this lesson will be to factor trinomials when the coefficient of x squared, or your leading coefficient, is not 1, but something greater than 1. It's going to be similar to what we did before when we factored trinomials with a leading coefficient of 1, but there will be a few additional steps. So pay close attention and take down these examples. So in order to factor, let's follow these instructions. It says find the numbers that multiply to be AC. That means A times C. And add to be B. Slide A under these factors and reduce if you can. Move the denominator back in front of X. Let's look at some examples so this makes a little more sense. So we're going to find the numbers that multiply to be 3 times 8 is 3 times negative 8 is negative 24, but add to be negative 2. Again, I will encourage you to please have some scratch paper handy so that you can write down each pair of factors as you try them. Again, I'm looking for two numbers that multiply to be 3 times negative 8 is negative 24, and add to be negative 2. Remember, as we discussed earlier, if you multiply two numbers together and get a negative answer, that must mean that one of the numbers is positive and one is negative. When we add the positive and the negative number together, we actually take the difference of the two numbers and apply the sign of the larger number. I see here when I add my two numbers together, I should get negative 2. That means that the larger number is the negative. So what I like to do is be very systematic about this. Again, I'm looking for two numbers that multiply to be negative 24. So I'm going to start by writing down 1 times negative 24. Remember, the larger of the two numbers gets the negative sign this time. I can see when I add 1 plus negative 24, the answer is negative 23, not negative 2. So then I'll move on to 2. To get negative 24, I could do 2 times negative 12. But when I add 2 and negative 12, I get negative 10, not negative 2. Then I'll try 3. 3 times negative 8 is negative 24. And when I add 3 plus negative 8, I get negative 5. Again, it's not negative 2. Notice I'm being very systematic in how I'm testing out the factors so that I know I don't miss one, and I'll eventually find my answer without going in circles. So I've tried 1 times 24, 2 times 12, 3 times 8. Now I'm ready to try 4. 4 goes into 24 6 times. And remember, these are going to be opposite signs. So I'm going to say 4 times negative 6. 4 times negative 6 is negative 24. And when I add 4 plus negative 6, I do get negative 2. So I have found the numbers that I'm going to be using, 4 and negative 6. So I start by simply setting up my factoring as I would before if my coefficient had been 1, x minus 6 and x plus 4. Please know this is not the answer. This is just part of the process. Since I do not have a leading coefficient of 1, but rather of 3, I will now slide the 3 underneath the 6 and the 4 to create fractions. Okay, so I'm going to say 6 divided by 3 and 4 divided by 3. Now, if you can simplify these fractions, you certainly should. And I can simplify 6 divided by 3. That's just 2. But I can't simplify 4 divided by 3. So I simply move the denominator back in front of this x. So this factor becomes 3x plus 4. In factors, we will not be leaving any fractions in our factors, generally speaking. And so 3x squared minus 2x minus 8 can be factored into x minus 2 times 3x plus 4. If you want to double check, you could multiply this binomial times this binomial and simplify, and you will end up with the trinomial that we started with. It's going to be very important in your mathematical career moving forward that you're able to factor these fairly quickly. So we will practice. In number 31, again, we have the trinomial a in the right order, ax squared plus bx plus c, where a is 4, b is negative 12, and c is 5. Since the leading coefficient is not 1, we must multiply a and c together. 4 times 5 is 20. I would write that down, 20. That's important. We need to find two numbers that multiply to equal 20, but add to equal negative 12, our b term. How do you multiply two numbers and get a positive, but when you add them, you get a negative? The two numbers must both be negative because a negative times a negative is a positive, but a negative plus a negative is another negative. So I know I'm looking for two negative numbers that multiply to be 20 that add to be negative 12. Again, I've got my scratch paper handy, and I'm going to start a very systematic list. I'll start with negative 1 times negative 20. Negative 1 plus negative 20 does not add to equal negative 12. Then I'll try negative 2 times negative 10. Bingo! Negative 2 plus negative 10 is negative 12. So the two numbers that I need are negative 2 and negative 10. So let me scoot this down so we can see that. So that is my first step, establishing that negative 2 and negative 10 are the two magic numbers I seek. Now, because the leading coefficient is 4, I will now slide the 4 underneath the minus 2 and the minus 10 to create 2 over 4 and 10 over 4. My next step is to reduce these fractions as much as possible. And I can reduce 2 over 4 to 1/2, and I can reduce 10 over 4 to 5/2. Remember, we don't want to leave fractions, so you simply slide the denominator back in front of your variable. So the 2 comes back over here. It becomes 2n minus 1. And this 2 in this fraction slides over here in front of the n, and it becomes 2n minus 5. Again, if you want to try multiplying the two binomials together and simplifying your expression, you will get 4n squared minus 12n plus 5. Let's do another. Let's do 6a squared minus 5a minus 21. Again, our leading coefficient is 6, so we must multiply 6 times negative 21. I'm definitely going to need some scratch paper to help me keep track of this because 6 times negative 21 is negative 126. And there are a lot of things that multiply to equal negative 126. The first thing I note is that my numbers will have different signs. I'll have a positive and a negative because a positive times a negative is a negative. I know when I add these two numbers together, I'm going to get negative 5. So the larger number will carry the negative sign for me. Once again, I'm going to be very systematic. I'm going to multiply 1 times negative 126, and I'm going to write that down. I'm going to note that when you add 1 and negative 126, you don't get negative 5. So then I move on to 2 times negative 63, which is also negative 126. But 2 added with negative 63 do not add to negative 5. Next, I try 3 times negative 42. Again, when you add 3 and negative 42, you don't get negative 5. I try 4 times, 4 doesn't go into 126, so I move on. 5 doesn't go into 126. I move on to 6. 6 does go into 126, so I could say 6 times negative 21. But again, 6 plus negative 21 is not negative 5. I try 7. 7 goes into 126 18 times. So I could say that 7 times negative 18 is negative 126. But 7 plus negative 18 is not negative 5. I move on to 8, which does not divide evenly into 126. So I move on to 9. You may be thinking, wow, this is a lot of work. Yes, it is, but by being very systematic, I know that I'm trying every combination, and I know I'll eventually get to the right answer if there is one. But when I find 9, I'm onto something. I notice that 9 goes into 126 14 times. 9 times negative 14 is negative 126. And 9 plus negative 14 is the negative 5 I'm looking for. Whew, that was some work. But I have my numbers now, negative 14 and 9. I found the two numbers that multiply to be 6 times negative 121, which is negative 126, and add to be negative 5. Now I take the leading coefficient of 6, I slide it under the 14 and the 9 so that I can reduce these fractions if possible. I notice that 14 and 6 can both be divided by 2, and I notice that 9 and 6 can both be divided by 3. So my fractions are simplified, but remember I don't want to leave fractions. So take your denominator, the 3 is going to slide over here in front of this A, and this 2 is going to slide over in front of this one. And my final answer is 3a minus 7 times 2n plus 3. It's a lot of steps, huh? So factoring trinomials is definitely one of the really important and sometimes difficult concepts that will help you in your math career moving forward. Let's try number 33. We're going to multiply 16 times 1. Of course, we get positive 16. I'm looking for two numbers that multiply to be positive 16, but add to be negative 8. Multiplying two numbers to get a positive that also add to be a negative must be two negative numbers, because a negative times a negative is a positive, but a negative plus a negative is another negative. All right, so I know I'm looking for two negative numbers that multiply to be 16 times 1, which is 16, and add to be negative 8. Again, I could be very systematic about this. Negative 1 times negative 16 does not add to negative 8. Negative 2 times negative 8 does not add to negative 8. But negative 4 and negative 4 multiply to be positive 16 and add to be negative 8. So I have found my numbers, negative 4 and negative 4. So I'm writing w minus 4 and w minus 4. But I don't stop there because my leading coefficient is 16. So I must slide the 16 under the 4's. Of course, next I will reduce these fractions, noting that 4 divided by 16 reduces to 1/4. After you reduce your fractions, if you still have fractions, the denominators slide in front of your variables, and you're left with 4w minus 1 times 4w minus 1, which could also be written as 4w minus 1 squared. Let's do an example with a greatest common factor. This is something we should always check for when we begin to factor. Notice that the three terms in number 34 have a common factor of 3. So I will begin by factoring out a 3. Come on, computer, stay with me just through this example. So I start by factoring out a 3, which gives me 5y squared plus 7y plus 2. Now I will be factoring this trinomial, and this 3 I will be ignoring for the time being. I'm trying to factor the trinomial 5y squared plus 7y plus 2. I multiply the 5 and the 2 together to get 10. I'm looking for two numbers that multiply to be 10 that add to be 7. It's much easier when everything is positive. The two numbers I'm looking for are 5 and 2, because 5 times 2 is 10, and 5 plus 2 is 7. Again, the 3 that I factored out earlier is just kind of hanging out there in the front. The number that needs to go in the fraction in the denominator is the 5, the leading coefficient of what I'm trying to factor. So I'm going to slide the 5 underneath this 5 and this 2. The 5 over 5 can be reduced to 1, but the 2/5 can't be reduced at all. So in that one, the 5 will just slide over here in front of the y. And now my trinomial is completely factored. And I will end this video before my computer dies. Thank you a bunch.